better.
Because it's in English.
Okay, and with that, good afternoon, everybody. Welcome back to Discrete Math. Plan for today is going to finish up on orderings, give you a little bit of time to talk with your neighbors about the orderings problems, and then we'll move on to our next unit on functions. And no, we're not like just like in Calc 1 necessarily, but define functions to be a relation on a Cartesian product of two sets satisfying some properties, that type of stuff. Usual office hours, day after class, tomorrow at 11 and 1, Wednesday at 11 and after class. And as far as homework goes, functions packet stuff. Any questions or comments before we get started for today? You should have a mistakes journal entry today. What did the acorn say on the day it grew up into a mighty oak?
Gee, I'm a tree.
Geometry.
Geometry.
Okay, so as promised, give you a little bit of time to talk with your neighbors about kind of the second half of the orderings packet before we go on to do our orderings presentations. So group up and discuss. And then we'll reconvene in like 10 minutes or so and start doing presentations on the packet.
So since Friday, I forgot the difference between fully loaded and partially loaded. Does anyone know?
Are we just gonna get back in our regular?
Say what?
Are we getting back into our groups?
Sure, if you want, or you can make new ones. I don't really care.
That's not okay. Yeah, I got you. So they mildly be related to one direction, right? Okay, so Tia is Tia must have the greatest element. So global, that's like global. So that would be true. Every element.
Do you want me to throw on one of the desks back here? No one sees them.
No, it's fine.
Probably one of the English majors. So
Oh.
that's
good.
Wait, it's
It's even warm this morning.
I said no. I said because not everybody's related.
Yeah, that's fine.
Because A is related to B, B is related to B, and C is related to least, because this is a question about a minimal
These are really
yes, correct. Since one does have a greatest and a maximum. Sorry, a great. What is it? Yeah, so it has.
Feel free to go ahead and sign up if you feel like you're ready for something. And in the meantime, I forgot something.
Yeah.
I didn't like doing all the groups.
I'm gonna go far.
Then must be two.
We said it was true.
Oh, partially
No,
ordered.
It was totally ordered. That was just
Oh,
like,
yeah, greatest
all
and
of
not.
it was
Like the one other.
So,
So like I just.
The second one.
like, yeah.
Yeah, and so,
I would say so.
like.
But doesn't it just mean it doesn't?
No, it does have a greatest and least, but it's not higher.
Yeah, I
literally just related it.
I'm still trying to figure out just does this mean that they're related if x is less than y? Does it mean for all y?
X will be less than or equal to Y.
Like the second one, like when I first started talking about them, like before the lattice stuff.
This?
No, it's like,
Oh, this.
yes, like I'm just looking at this and all these things. I'm just like I have no clue.
It's like X is
Okay.
I should probably just read the book because we have a textbook that goes over this. I should just read the book.
I mean, if it has a greatest.
It's just not a material error.
Yeah. Like, so that is this case.
Yes. Okay, so with equals, we use solution of like so then but I would not like to put sure.
I just turning it dry.
I can't glare.
And then next day she was like, oh, every time you said that.
Maybe, I mean, I guess I did.
Yeah, I do.
So, I didn't figure that right away, yeah.
What's the counterexample? Okay.
Two elements.
Because D and F aren't
Each other, right, either A
So, like-
or B or B.
Oh, so it's greater than.
There's a greatest and a least.
Would be an off-topic
But
question.
it's
You're in the
not
definition.
word.
Oh.
You can't get from these
How much work do you put in
by going up.
Gotcha.
I took AI this semester and I was about to get into for the heck of it next semester, but I'm like, it seems he assigns a few too many problems.
Wait, so does a totally ordered set have to be fine? But like, I don't know if you.
Because I was thinking for B, it could be like the set of ten.
I was thinking about it, but I'm like,
Well, would that have a
this
greatest
is my
element
ton
though?
of homework problems, and even if you kind of know what you're doing, it's gonna take a while. I just have never had like a formal.
Or I think that you should just
I've
like
kind of figured stuff out on my own, but don't really know what
present that and just
so I
pose
know
that
how it
question and
works,
don't write
but
anything
I still
down
like
until someone answers.
I wanna try.
Wait, Dr. Durso,
Are so.
does a totally ordered set have to be
So hard, like I like
By page numbers.
like
Ours,
other this kind of software. So it kind of.
Not necessarily. Guess so?
We have 1, 2, 3. Okay, I think I was right. Yeah.
I think you're doing the.
If you can think of an infinite counter
No.
now,
About that
Too
one.
much at work, I want to do job.
Student structure is a 201 or
Well, if it's
201.
in,
201.
it's like
Okay,
that.
I'm doing that one next semester. Well, hopefully.
I mean, if you're doing like A plus.
I was wondering about if I should take the intro.
I'm gonna try and get, I took one this
Or
summer,
maybe A is greater.
like from State University or something. I'm gonna try and get
Yeah,
Hopefully you can.
so what is,
That
so
would be like,
what's
if
minimal?
the rule is like,
that. I need
like,
that.
I can write a lot.
Nothing is left.
I finished it, like this morning,
Doesn't really
was
matter
writing all the.
because they're not really, so you
Still need to do some of this.
I guess they can.
For at least if everything else is greater than this.
I was just curious, cause.
Are you sure that's not, that those two mean the same thing? Something to think about. I think that one's not quite as obvious as you make it out to be. And
So wait,
think
I did not
think
have.
about this question. Is it possible for a set to have multiple
Yeah, that one
minimal
never
elements?
installed.
And is it possible for a set to have multiple least elements? Something to consider. Yeah, go grab some.
It was weird. I just saw Peaches doing it.
Definitely not.
Are there any cases where A is not really the thing? I guess you can make it like where A must be less than.
In either of these sets, I think X must be related to X. Yeah.
Because software
in this
development.
case-
That's why I'm not taking. I don't want to. Math, you can use it.
Oh, are you thinking like it's a counterexample?
I'm sorry, multiple max minors.
I should do it later. I think there's a couple seniors who have been through it. I'm gonna have a couple something. No.
All the group's done. Looks like you all quickly went to sign up for stuff. Let's go ahead and take like 2 or 3 more minutes before we start doing presentations. So, and then we will jump in from there.
How are take-homes coming along?
They're coming along great, sitting in a stack next to my computer. Why do you ask?
I'm just,
They're coming along great as being let me rephrase. They're coming along great as the 3rd exam that I got back to grading within like a 3-day time span.
Just gotta get a grader.
I'm gonna get a grader Oh yeah, get a grader for a topics class.
Well, I mean, the TA to grade your like calculus stuff.
I can't get a TA to grade my calculus stuff. I have a weird calc grading system.
Oh, with like your mastery stuff.
Oh,
Yeah.
But like,
I can barely.
I think it.
Masters for everyone. Yeah, I mean, you can speed up your grading for our class. You just throw an A on the top of all of them.
He's got a point. Actually, I think
Oh, okay, I
you
just
should
failed.
let Adam be I think Adam would be a great TA for this course.
I'm already TAing for a class, so you have a limit of 1.
I was gonna say, you're not wrong. So here's the thing, if I don't hire a grader, that means I get more money for professional development purposes.
Oh, really? Is that how it
What
works?
does that mean?
I don't know if that actually is how it works, but that's what my case I'm gonna make to Dr. Shore.
We need more funding in the math department, because currently professors are only allowed to have a TA for 1 semester out of the year, which means that I was almost out of a job when Dr. Bolasov told me that. But thankfully, I was able to pivot and will not be unemployed next semester.
Oh good, I'm glad to
You're
hear.
so worried about your unemployment.
I was gonna be like
Of all
starving
ages,
myself.
the
You're gonna be like starving out on the streets, huh?
Exactly.
Without that high paying reading.
I was gonna be sitting in the math department with a cardboard sign.
Okay, let me know.
Will grade for money.
Exactly.
There is also, by the way, someone.
Honestly, I would really
That's
enjoy
specifically
like just grading PowerPoint exams.
Would anybody still like the chance to sign up for a presentation? Hasn't yet. Alright.
This can't be sanitary. Just like there are like a few little like dents in the fringe, like probably.
Shoot, I don't think I signed up for that.
My
I
water
signed up for
bottle.
page. No, I signed up for page 7 and I wanted to sign up for page 5. So hopefully it's easy for page 7.
Oh, that one.
For me, like if there was like old like down, I think I'd be really concerned.
Yeah.
But like it's just so easy for a couple.
Do not want to do page 7.
No.
I signed up for the wrong problem.
Did you? Would you like to change?
Well, I meant to sign up for page 5, but I signed up for page 7 instead. So,
Okay.
For a while.
I'm here.
Having you missed my
One
presentation.
of the longest lists. So many other options.
Yes.
There's so many things I can't count them. Everything wouldn't count them.
Alrighty. Lily, you want to kick things off for us?
Yes. I'm looking back and trying to remember the logic of what I wrote, so bear with me. So for the our group for the what we said are which orderings were total, we said the only total ordering would be the first one on the page because all integers are related and could be written, fulfill both of the parts of the, so the definition of a total ordering. As written is that it is a partial ordering. And given any may be in S, oh, on the set S. Either A is less than or equal to B, B is less than or equal to A. So we said that for S equals all of real integers under the relation less than or equal to would fulfill both of these because it is a partial ordering, and we showed that. Do you want me to show that? Why it's partial ordering? Like on the first page? Okay.
That sounds like a lot.
Okay, so we showed that it is it fulfills all the requirements to be partial ordering, and all elements in this set can be written as either A is less than B or B is less than A. Let's hear the next one, where S is a set of all real numbers under the relation, or where A is related to B if A equals B. We said that could not be ordered this way because there's not. I don't know. Wait, what did you guys say about that one? That it's also not.
Because S is all real numbers, and the only things that are related to each other are themselves.
Right.
So that means like if A and B are both real numbers, A and B are not related to one another.
Yes, I think that's what we discussed as well.
Distinct.
Yeah. There's no way to order them in this fashion because they would be equal.
So can you give a counterexample of an A and a B where neither is less than or equal to the, or neither is related to the other?
Yes, so where 1 is not equal to 2. Is that what you're saying, where they're not?
Okay, so 1 is not related to 2, and is 2 related to 1?
Yeah.
Then that sounds like it breaks condition number 2 there. You have a counterexample of an A and a B where neither one is related to the other one.
Right. Okay, yes. Okay, and then the last one, okay, I also have a counterexample for this one. Now I'm remembering. Okay, so the last one we talked about was the power set where S can be any set under the relation subset. So we said that again, it is a partial ordering, but it is not a total ordering because not everything in the power set can be related to one another. So we gave the set example 1, 2, and then we wrote the power set null, 1, 2, and then 1, 2. Since we cannot say that 1 is a subset of 2 and vice versa, we said they're not all related. And this also breaks. They can't be, it breaks this condition similar to this because they cannot be said to be subsets of one another. Any questions?
Your comments below? Okay, nice job. Next up, Mariah should be drawing us a lattice.
Yes.
Okay, so on page 5, we have the set T equals A, B, C, and we want to draw a lattice diagram for the power set of T. So the power set of T equals the set including the empty set, A, B, set all of them. Yes, okay. So we're gonna work our way, so the relation is subsets of, and so the null set is gonna be at the bottom of the lattice diagram because it's a subset of all of the others, but the rest of them are not subsets of the null set. So empty set at the bottom, and then this set including A, this set including B, this set including C are at the next level of our lattice diagram, and we can draw lines to each of them relating to them. Then the next layer is going to be the steps with two elements, E, AC, and BC. A is in this one, and this one, so it gets lines. B is in this one, and C is in these two. And then the only element we have left is ABC. Sorry, this is blurry. So all three of these are subsets of ABC, so they also get ones. Any questions? Yes, Dr. Crystal.
Hi, nice job, Elmira. I'm curious, is there a way to, do you know if there's a way to make, do this lattice diagram, I can speak words, so that none of the lines intersect each other?
My knee-jerk reaction is to say no, because we got a hint informing us that it was okay to make them overlap. Let's see.
You don't actually have to answer that. I just said that as a teaser because that might be something we're talking about in a few packets from now.
That's exciting.
We get to graph theory.
If it's 3D.
It's what?
If it's 3D, you don't have to.
Sure, I guess sure, if it's 3D
If it's,
in a two-dimensional setting.
but then again, if it's 3D, wouldn't that would be putting like, if we look at like a cube, like A, B would not be on like the same like level as AC, or AB and BC would not be on the same as AC. Because like AC is like, technically it would be on the same plane.
It'd be a lot harder to read.
Here.
Okay, nice job. Okay, next up is Griffin.
Hello. Here's this question number 7. I'm gonna start by just drawing this lattice, because that will be helpful in answering the question. So we have F, related, or E is related to F, and then D over here. There we go. So this is the lattice diagram that we were working with. And so the first question is explain why D is the maximal element. And if you look on the previous page, the maximal element is defined as X is a maximal element of S, where there does not exist any element Y such that X is greater than Y. In other words, no element S is strictly greater than X. D is what we are looking at here. And so because here we have D is not related to anything, no, that's not what I'm trying to say. So one thing that I did that I found helpful was drawing arrows on the top of each of these, because here we have that D is related to D. D is related to D, but D is not related to B. And so it is a maximal element because there is nothing greater than it that it connects upwards to. Yeah, I don't love that explanation, but that's what I have. So the next question is explain why D is not the greatest element. And so you can only get a greatest element in a total ordering. And here, as you can see, D is not related to F, and E is also not related to C. But pretty much in a total ordering, any two random elements that you pick will be related, and not all of the elements in this lattice are related. And so the last question is, does S have a greatest element? If so, what is it? And there's no greatest element because this is not a totally ordered diagram. So, any questions? Yes, Marat.
Okay, I don't know if this is gonna come out coherently, but you said that in order to have a greatest element, it needs to be a totally ordered set. But if you just have a single element that any other element is related to, even if the other elements aren't related to each other, could that element, like, if there's an element and if you pick any other element, there is a path to that first element, that would still be the greatest element, even if.
True, yes, if we had,
You're saying like if D.
if we had that or something like that, where like B and C, yes, you're right, this does have a greatest element here. So that was incorrect, thank you. So the reason this does not have a greatest element is because it is not, is because that all elements are not related to what looks like the greatest element, which would be F. But we don't know the relationship between D and F without that line.
I would say we do know what the relationship is and that there is none.
Okay, yes, that's what. Yes, Holly.
So then, when we're looking in terms of F, would F be considered a maximal element
Yes.
in this case? So D and F can be maximal elements, so you can have more than one.
Yes.
Okay.
Yeah, because the way we talked about it in our group was like local and global maxima and minima from like graphing. So they're kind of like local maxes. Yes.
And kind of to follow up with that, you can only have one greatest element, is that correct?
Yes. All right.
As per approved portfolio problem number 2.
All right. Thank you.
Well, that's been good questions.
Well, Griffin pretty much just answered this one. So, next one is, if S is a partially ordered set and X is an element of S, then X is minimal if and only if it is the least element. And we just saw that we could have two maximal elements, so the same thing can be true for minimal elements, and so I'll just give a counterexample. And then I had so in this case, A and C are both minimal elements, but they are not least elements because A and C aren't related to each other. So we just had the big discussion with Griffin, so I don't know what else to say now. Are there any questions? So this is false.
Ooh, I got a question. Maybe it's a little too much, but can you name a set in which this could be the case? Like a relation, like a defined relation where like that would give you that lattice.
Oh,
Like a real world example, you mean?
yeah. I do not have one in mind, no. Does anybody else have one in mind? Dr. Gerstle?
I'm trying to think. Let's see, what would be one that could give this? Okay. Hey Jacob, can you do me a favor? Have a put a one going down from B to another letter E.
Like down here?
Yeah. Okay, so A is the Dean of Natural Sciences, C is the Dean of Social Sciences, E is the Dean of the Humanities here at Hillsdale College. all of those have to answer to the provost, Dr. Van Orman, so he could be the element B. And then there's someone even above him, element D, namely Dr. R. And the relationship is a subordinate of, let's say. Does that work?
Yeah, absolutely.
You can have one going from D to Pat Takehouse. Any other
questions? Great.
all right, nice job. Okay, next up we have Laurie with part B.
So my question is, if T is a totally ordered set, then T must have both a greatest element and the least element. I thought this was false because in the example that Lily is doing, the set or S equals the set of integers under the relation less than or equal to is infinite. So there can't be a least element. I don't know.
Yes. So I'm not sure I completely follow your logic. So a totally ordered set is a set in which any two elements are related, right? You can pick any two elements and there's a relation between the two of them. And so if there's a relation between all elements, doesn't that mean that because there's that relationality that you will have a least and a least and a greatest because there's no undefined relationships there.
Well, for the set of all integers, there's no smallest integer, so there can't be a least element.
It's turtles all the way down. You keep having one turtle underneath the next one, but there is no bottom to the stack of turtles. Okay, that's my real world example.
Dr. Gersten?
I have a question, Larry. You said that because the set is infinite, it can't have a least element?
Yeah.
Is that true in general, that an infinite set can't possibly have a least element?
Probably not. I mean, if it's from like zero, if it's the interval like 0 to 1, I guess you could have a least element.
Ooh, okay. So for like, I assume we're talking about real numbers now?
Yeah.
So there's infinitely many real numbers between 0 and 1, and so there is assuming we're looking at the closed interval, there is a least element 0 and a greatest element 1, even though it's an infinite, totally ordered set.
Yeah.
I like that one. That's better. I like that one better than the counterexample I was thinking. Any other questions for Lloyd? All right, nice job. And let's see, last up we have Alex for part C, the final one.
In the finite case, is it true that a totally ordered set will always have to have a least and a greatest element?
If we have a finite set, will a totally ordered set have a least and greatest? Yes.
Okay.
Which I think would be something you could prove by conjugation.
For this last problem, it asks if S is a partially ordered set with both a greatest element and a least element, then S must be a totally ordered set. And I also found this one to be false with the following counterexample. So here, the lattice diagram, the set with 4 elements. A is the greatest element, because all upward paths lead to it. D is the least element, because no downward path extends from it, and all upward paths extend from it. However, B and C are incomparable, so this is not a totally ordered set. Any questions? Dr. Gerstle?
I'm sorry, you said D is a least element because there are no paths extending downward from it?
Is that what I said?
I think that's what you said.
All paths extend upward from it.
Ah, so like in other words, there's a path from D up to every other element? Yeah, I was gonna say, no paths going down from it I think just makes it minimal, which is not quite the same as saying least. Any other questions or comments for Alex? All right, nice job. Yes, have need of me. I gave you 3 questions that said prove or disprove, and it turns out all of them were disproves. Okay, so that's going to do it for now for relations. Now, we've kind of looked at several types of relations. We've looked at equivalence relations. We've looked at partial and total orderings. We've looked at relations that are none of those things. And now you're going to go on to our next major topic, which is the topic of functions. So before I pass out this packet, when I say we're looking at a function in a mathematical setting, what do you all think of?
F of X.
F of X. Oftentimes the most commonly used name for a function in math, probably.
So like inputs and outputs.
Ooh, tell me more.
So for a function, hold on. Every input must have an output, but one input has, oh my gosh, this is going back to 8th grade. I know at least like, there corresponds like 1x to 1y, like or multiple x's can correspond to 1y, right? But 1y can't correspond to multiple y. Yeah, it's switched. Okay. You know what I'm trying to say, Dr. Gerstle.
I think you're trying. So if I had to guess, you're trying to say a single input can only have one output, although multiple inputs could potentially have the same output.
Yeah, my brain couldn't say it though.
Yeah, like if my function is a machine that takes in students in the class and spits out their final grades. Madeline, would it make sense for you to have multiple final grades in the class?
No.
Probably not, unless you irk me too good. Olivia, is it possible for you to have the same final grade as someone else?
Yes.
With that attitude, sure. Okay, all jokes aside, that would be a function, even though like it's possible more than one of you gets an A, or maybe more than one of you gets a C. Although, so multiple inputs can have the same output usually in a function, but it wouldn't make sense to have one student just have multiple final grades. One input can't go to multiple outputs. So, let's see. So, here's the packet. We're going to define functions in a funky way. Not a fan? My apologies. So here's how I'm going to define a function. A function, f, is going to be a relation on the Cartesian product of two sets. And we want two different. So first of all, what does it mean to take the Cartesian product of set A and set B? So what do elements in this set look like?
Like ordered. That's what I was gonna say.
Laura?
Ordered pair.
Yeah, ordered pairs where the first coordinate comes from and the second coordinate from. Yeah, exactly. So we can think about this as being a collection of ordered pairs. And we want a relation on this, where if you recall, we originally defined a relation to just be a subset of the Cartesian product of a set with itself. Guess what? Now we're expanding our minds and allowing it to have two different sets. Where you can think of A as being the set of inputs and B as being the set of outputs. And the two conditions we want is that for all elements little a and big A, there exists some little b and big B such that A comma B is an element in our relation. Yes, I just said A comma B is an element of F. Didn't see that in your calc classes, I bet. And the second condition is that if A comma B1 is an element of F and A comma B2 is an element in F, then B1 has to be equal to B2. So for a quick example of what this might look like, we could say that if A is the set of all of you, students in the class, and B is the set of all possible final grades. Yes, I know this hasn't been established yet, but let's pretend like you've gotten final grades in the class. Then we could say something like, Jacob comma C is an element in our relation. Basically saying that F is a subset of the Cartesian product of A and B, all possible combinations of students and grades, which saying that Jacob comma C is an element in F, I would say is equivalent under the way, Griffin, you're used to thinking about functions, of having Jacob be an input and the grade of C be an output to the function. So basically, we're defining functions the way you're used to thinking about them, just with different what's the word I'm looking for? Notation. And that when we define a relation as being a subset of the Cartesian product, we're going to say that Jacob comma C is in here just means that if we were to plug Jacob into the determining final grade function, C would be the output given the input of Jacob. And we would say something along the lines of Jacob comma A is not an element in F since F of Jacob is not A. That makes sense so far? Jacob, it makes sense?
Yeah.
Oh, it does. And if it made sense, you would map to an A.
Yes.
Okay. Well, I'm not planning on such a cruel example. So, y'all, the rest of class, work on this packet. Let's see. How do I do groups? I don't want to do that because you all are always. Okay, let's do it this way. Who's wearing blue jeans? Let's see. Let's have a group of Lily, Alex, Laura, and then a group of Jacob, Adam, Madeline. Raise your hand if you're not in a group.
You're not what?
If you're not already in a group. Olivia, Lori, Holly, Griffin, Helen, Mariah. It's called you, Madeline. Griffin, Helen, Mariah, Evan. There, you got your groups? Everybody is now in a group. Okay. Sophie, pick a group and join. Sorry. Really? You weren't holding your hand up high enough.
I'm sorry.
Where's the easiest?
Totally ordering.
What is it?
You and Aaron one direction and you have groups and stuff like that. We never had that.
Can I join?
I think there's an option in ours for direction. We just have to get there.
Oh, is
Well, we
there a
also have
question?
very different projects, so
That is
I don't know.
Oh,
So,
okay.
so like,
There has to be, they can help with whoever.
Does there have to be for K? Does there have to be each element in A? Wait, no, H is wrong.
I think so.
Yeah.
I mean, it's just a different way.
H is wrong. The one that I'm wondering about is K though. Because so it has some of the inputs, not all of the inputs.
Is that just the definition of a?
Yeah.
But it's not, it's just saying, are they on?
you can give like examples.
All of them. And I think, but I changed it to A. Or is that what that?
Condition number 1 says every element in A needs the corresponding B to it.
And I guess A would mean
Something to think about.
an input
Oh.
in this case would be,
Every
an
element
output
is not.
that's the same corresponding to every input.
Okay.
Jacob, let me know if you'd like me to make someone else be the butt of my joke.
Oh, no, it doesn't bother me.
Okay, good.
This first one.
Oh,
works
that
just
one's
as
saying that
you-
you only have one output, or every input.
Okay.
Because it's
So
like,
like
oh,
the
oh,
A,
I thought it has to be like,
Hashtag
that they were like the
all
same or
the
something. I was like, what?
They all have.
Oh, then that makes
And all
sense.
they're all in the.
Can you ever think back and just be like, second grade me would be so impressed right now,
Yeah.
doing math off letters.
Look how far you've come.
Okay. Explain why that's
Second grade me would be weirded out. So I'm like, wait, you're a math professor? Why did you do
I
that?
don't have a reason for that.
You messed up.
That was not part of the second grade plan.
But even if it was U cross A, it still wouldn't be because E is listed twice, so you would have multiple outputs. No, because if it was B cross A, then there could be multiple E's because it's cross A. True, yeah.
Okay, I think this one, the
But,
first
yeah.
one is a function. Because Lily and
Okay. Next one's okay too.
Really?
Yes.
Goes on the next
So like, it would just be
I think
wrong
so.
A
Yeah.
maps to two different methods. They can all map to the same one. But each one has a unique output.
why do they actually
Yeah, it should be, because each input.
So see, like, look at it, the next one is wrong. So like A maps to two different, almost different things.
So, there's a unique output for every input?
That's a, I don't see. But like, me, like, pure P, both have,
But we're still seeing that each input
if we
has
both have Cs then.
one output, right?
Yeah.
So I think we're taking
Don't drag your classmates down to your level.
oh, that's true.
Oh, it doesn't define it. Yeah, I thought it was just saying it was in a function.
Maybe I click it late. I think it's fine.
There's not a little a in every element.
I wonder, does that matter if you keep going? It's like now a different, like a reverse function.
Well,
We still have to
would it be a
like,
function on the same Cartesian product? Is A cross B the same set as B cross A?
I don't think so.
I think they're different sets, and so I would say a function on one set doesn't define a function on the other, although it's, if perhaps you say had an invertible function, you could say, well, a function from one first to second could create a function from second to first. That's next time.
So unless A and B are reversed.
Is your class just going right now?
Oh, hi Katie, coming to sit in on the street.
I watched 2 minutes after, so I'm sorry, I thought class was over.
You thought wrong. Although come to think of it, you thought right because class is over.
Oh, whoa.
So we are out of time for today. I'm gonna do something bold. We're gonna start class with presentations on this packet next time. I think this packet's on the easier side of packets, honestly. So encourage you to work on these packets, and then on Wednesday we'll start class with presentations. And in the meantime, you're welcome / encouraged to work with each other on this packet and to come ask me questions.
Dr. Bruce has been taking shots today. He called me a jerk. He gave Jacob a C. He yelled at him in class.
I mean, I'm teaching a class, so someone not in the class shows up. What do you want from me? I don't. She's an actor. She actually is in one of my other classes.
So you're allowed.
She knows me well enough to know that if I yell at her, I'm not actually upset.
Doctor, so I won't be here Friday because of basketball, and then we leave for Alaska next week.
Ooh, Alaska.
So I won't be here then next Friday.
Of course.